All right, so we've been practicing and reviewing how to combine like terms. The reason why we did that is so that we can apply it to equations that have this skill. So it's going to work exactly the same in equations. What you do as far as combining terms, exactly the same. So when we're looking at an equation, we always kind of look at the side with a variable. So that's kind of your first step, always and forever. You identify the side with a variable. And if you look at your example, this is on the top of page 3 of your note packet. If you look at this example here, what I have highlighted here on the left is my side with a variable. So you should notice that there are like terms, and we want to clean it up because this is one of the ways that we can simplify. This is the first way that we really simplify things. So just like we did before, um, there are terms that are similar that we put together. All of our x terms can be put together, and all of our constants, which are those regular numbers, can be put together too. So down here is just kind of a color-coded picture of it. So again, we've got these four terms, 15, positive 4x, positive 10, and a negative 3x. And again, we can put our blue terms here together because they both have an x value. So when we put the 4x plus 3x, I'm sorry, plus a negative 3. So when we put those two together, we're going to get the answer here of negative 1. So again, those two blue terms on the top have combined to be a positive 1x. And then our red terms here, those are constants, those are regular numbers, so we can also put those together and kind of simplify. So it's 15 plus 10 is going to give us the value of 25. Now we're ready to solve using the inverse operation. So guys, what we're doing is we're essentially just adding on another step to look for and kind of work through in your questioning process. So again, we mostly looked at identify side of the variable, then we undo addition and subtraction, and then we undo multiplication and division. Again, now we're looking at problems that we're going to add on that extra step. So once we find the side with the variable, you want to ask yourself, are there any like terms I can combine to simplify first? Then you're going to undo addition, subtraction, undo multiplying and division. One thing I do want to make sure that you're aware of is that when you're combining like terms, notice how I just took the symbols that I see, right? 4 minus 3 and got 1. You're not using any inverses, guys, until you get down to these bottom two steps. When it says undo, those are your inverse operations. When you're combining like terms and when we get into more steps with the equations, that is when we are just looking at the operations on that side. It's almost like, again, in this example, we rewrote it, but you're kind of really ignoring the equals 12. We're not doing anything with that until we're ready to solve, until we get down to these steps right here, guys. You're using the signs and symbols how you see them and cleaning up one side. All right, so moving on to the next page. So there is another example in your note sheet that you can review on your own. It just gives you another reference to go to. So we're going to jump down to these bottom two here, and we're going to try these together. So again, when we're following these steps procedures, I'm actually going to go back and grab that chart, because I do think it's helpful to guide your thought process. So when we're looking at this equation, the first thing you want to do is identify the side of the variable. That's always first and forever. So I'm going to go ahead and we're going to look at this equation right here. See if I can blow this up a little bit, make it a little larger. All right, so if I'm identifying the side of the variable, here it is here on the right-hand side. Then I'm going to start my list. I'm going to combine any like terms that I see. So just like we kind of did before, remember, like we think about boxed terms, so I can even throw in my little lines there. We have a positive 2, a positive 3x, and a positive 4. So looking at boxes here, hopefully you realize that you can combine the constants or those regular numbers. Those are like terms. So 2 plus 4, again, applying, we're kind of totally ignoring the equals 24 right now, right? Pretend that doesn't exist. We're just looking at the signs that we are seeing. So 2 plus 4 is 6. Now my 3x, that doesn't really combine with anything, right? So it's just going to drop on down and be added to my problem. So the 6 is the combination of those two terms that I can put together. My 3x drops down, and I'm just going to rewrite my equals 24. Then from there, step 1 is done. Now we're going to look to undo addition and subtraction. We have a 6 and a 3 with our x. This is multiplying, This is addition. So we're going to take care of that 6 first, and we're going to subtract it. This is where I use my opposites when I get down to those bottom 2 steps. We have 3x equals 24 minus 6 is 18. So we undid addition, subtraction. Then last but not least, we're going to undo multiplying and dividing. This is multiplying here, so we're going to undo it by division. And we get x equals 6. All right, so let's take a look at this last example here. Again, you're going to follow the same thought process. Okay, so first we're going to look at the side of our equation here that has our variables. This time it's in the more desirable spot. We're used to equations having the variable on the left, so this is a start of being a nice looking problem. So from there, again, first question, do we have like terms to combine? So we did box them off in class. If that is helpful for you, here's your boxes. You have a -3, a +7, and a -5x. So in this example, we do have like terms to combine. Again, they happen to be the constants that I'm going to combine, the regular numbers. It could be the x values, it could be the regular numbers, it could be anything. So don't get yourself into the thought pattern. It can only be the numbers. There is a bunch of different combining like terms problems, and we're going to do some more practice tomorrow. So those two terms, when I put them together, again, I'm just looking at one side of the equation. I'm not crossing this line yet at all. So I'm going to use the operations as I see them. So -3 plus 7 gives me a +4. Now that -5x box, it doesn't have anybody to combine with, so it just drops straight down. And we're going to then go ahead and rewrite the rest of our equation, equals 29. So we have done the first step, which is combining like terms. Now we're down to a traditional 2-step equation that we've been practicing. So the next step would be to undo any addition or subtraction that we see. So we're looking at right here. Hopefully you see, again, this one is kind of written a little less traditional. We have a 4 and a -5 with the x. This is my single term. This is my -5 times x. So we'd be moving the 4 first. So +4, because again, we look at the sign out to the left. So we're going to go ahead and subtract 4 on both sides. Now be careful, guys. See how you can see it nicely with the colors here, but I got rid of just the 4, right? So that negative has to make sure to travel its way down so that you don't lose sight of that. So we have -5x equals 25. Our second step here is to divide by -5 on both sides, and we get x equals -5. All right, so as I mentioned, tomorrow we're going to be doing some more practice with things and combining like terms, adding that step into solving equations. But hopefully this gave you kind of an idea of how we can apply to equations, get your thought processes, how you work through that steps procedure every time. We're going to work on some problems tomorrow, and I'll do some more examples with you that we may skip one of these steps in between. And that's okay, but this kind of helps guide your thinking. So again, this was the note sheet on page 23. You get participation points for following along in class, or if you just watched the video, make sure to fill out your note sheet and submit a picture.